Alright, perfect.
Like
What time?
9:15.
Wednesday? We leave at 10.
Oh, so we'll be here. We'll be here for something.
Oh, yeah, we'll be here for after.
Alright. So, I have a test tube here of water, not test tube, a beaker here of water. Who knows what chemicals are in there? I have a beaker of water here. Raise your hand and give me your best guess as to how many water molecules are in here.
Oh,
What?
molecules?
How many
Wow.
molecules are in it?
Rachel?
6.
6 water molecules.
At least 6.
I hope there's 6.
I feel like they're. I feel like she's close.
60,000.
I touched only one there.
Yeah.
Well, we need
No,
to
you're
measure.
like
We
0.5.
need to measure how many ounces or whatever in there. Multiply it by 6.022 times 10 to the 23rd.
Wait.
No. Nope.
How many ounces are
We'll talk about it. Okay. So.
Avocado! Avocado! Guacamole! Yum! I love this.
Okay.
What?
Settle down.
Avocado.
Settle down.
What just happened? You just like bad.
First of all,
Okay. So.
Avocado!
Can I continue? Okay. So.
Guacamole.
I say that kind of jokingly, guys, because it's kind of impossible for you to be able to answer that question, right? Yes. Okay? So how do chemists work with such little tiny molecules? Can we count them?
Yes.
Can we figure out how many molecules are in here? How do we go about doing that? Okay? Because atoms are so small and nearly impossible to count, scientists have derived a unit called the mole
Oh.
for
my sister
counting
complained
atoms.
so much when she was in high school.
have
My
older
sister
sister
complained about-
too.
Yep.
Complain about what?
Mold and stuff. This is
Oh, you won't complain about it. This is fun stuff.
Are you sure she was talking about like?
Cut. Now listen. Man, those moles on my face. they
Well, she's
bother
doing
me.
chemistry.
Okay.
No mold!
So, what we're going to be doing this chapter is really the math of chemistry. So this chapter is almost, I bet 90% math. Okay, you remember? Do you guys remember chapter 3 when I forcibly made you convert units a specific way, and I specifically said you cannot move the decimal? Do you remember that?
This is when it.
This is why.
This is the exception.
Okay? Because we're going to do all kinds of conversions in this chapter, and none of them are metric conversions, which means you couldn't move the decimal even if you wanted to. So, the point of that was so that we could get a handle, or at least start getting a grip on how units cancel out, how to do that process. I promise, guys, it's not as bad as you think if you stay with it.
like math.
Okay, I think you'll like this, man.
It's better than vocab.
Bet.
Okay.
The only math I like is geometry.
No.
Bet.
Bad.
Okay? So, the mole.
Bad.
Is it really that hard to just put the E at the end?
To be honest.
I mean, come on. That's true. I agree. You'll find that actually it's quite helpful because we're going to be doing a whole bunch of conversion factors. We're putting the mole as a unit in a conversion factor. You have to have a bigger conversion factor.
I'm gonna have to write one less letter.
Okay, yeah, anyways, the point here I'm trying to make is, how many of you have went into a candy store?
Yes.
Like, you went into a candy store. How many of you have bought jelly beans at a candy store?
All America.
Okay? So, you walk into a candy store and you go, hey, I want 2,000 jelly beans. So they're like, all right, hold on, 15 minutes, I'll be back. You know, and he goes in the back room and he starts counting one jelly bean at a time.
That's not me too.
Okay? Do you think that's what they do?
No.
What do they do?
They shove them in the back.
They don't have prepackaged. No. What do they do?
They
They have a dispenser.
No, they don't have a dispenser. What do they do? No, they don't guess.
Use molds.
No, they don't use molds.
Wait,
I didn't hear you
you
What?
Wait.
Wait.
Oh.
They count jelly beans by weight.
One jelly bean weighs a certain amount.
Yeah, one jelly bean. Now, not all jelly beans weigh a certain amount, but they take an average of what a typical jelly bean would weigh, and they put it on a scale and say, well, I know that 2,000 jelly beans weighs approximately 4.2 grams. So they fill up a container until it gets approximately 4.2 grams, and they can say, hey, here's approximately 2,000 jelly beans. You may get 5 more than you're supposed to, you may get 5 less than you're supposed to, but approximately you're getting your 2,000 jelly beans.
If they say they gave you 2,000 jelly beans, but they didn't, could you sue them?
In this day and age, maybe.
I got 1,900.
See, this jelly bean, this isn't a real jelly bean, this is half a jelly bean. Anyway, so the point I'm trying to make is what we're going to do in this chapter, and what we're going to do quite a bit in this chapter, is we are going to essentially count how many molecules, atoms, formula units I have by mass. So how do we do that? The mole is how we do that. And I will show you in a little bit what's so significant about this number, because you're probably looking up there and going, that's a weird number.
Yeah.
And the answer is yes. It is a weird number. Okay? Here's what the mole is. Gross. Here's what the mole is. It's a number.
Wow.
Hey, man.
Mind blown, right? It's a number. Okay, so let me kind of put this into perspective. Okay? If I have a mole of oranges, how many oranges do I have?
I don't know. Do math.
Oh!
You have that.
Mole rat.
What is the number? No. What is the number?
Oh, bag.
Oh, 2 times
6.022 times 10 to the 23rd. I have that many oranges. Now, that's a lot of oranges. Okay? If I go and I say I have a mole of golf balls, how many golf balls do I have?
6.022.
Okay? If I am really hungry and I buy a mole of cheeseburgers.
I could eat
Wow.
6.022.
How many cheeseburgers do I have?
That's a lot of cheese. Wait, that is not true.
If I have a mole of tanners, Lord help us.
Amen.
How many tanners is that?
Would that be
6.0.
Okay, now listen very, very carefully here.
Why?
Okay? If I have a mole of apples and I have a mole of grapes, do they have the same mass?
No.
Yeah.
Oh, depends.
Absolutely not.
I don't know. Wait. You have a mole.
Oh, yeah.
If I have a mole of apples and I have a mole of grapes, do they have the same mass?
Oh,
Are you saying singular grape
no, I
or
see now.
apple?
That makes
Or
sense.
Singular grape, singular
There
apple.
we go. Now
Okay?
that makes sense.
If I have a mole, that many apples, and I have that many singular grapes, do they have the same mass?
Absolutely.
Absolutely not.
Because you have 6
So-
bajillion apples and 6 bajillion grapes.
And an
That's
apple.
not
So let me ask you, if I have 12 grapes and I have 12 apples, they have the same mass?
Oh, where'd this come
On the floor.
Are you with me?
from? I got it.
See, here's what I'm trying to tell you. A mole is a number.
I know this one.
It's a number. Have you ever heard of a ream?
Yes.
A ream of paper. A ream is a number. Do you want to know what that is?
No.
500. When you have a ream of paper, you have 500 pieces of paper. When you go grab a pack of printer paper, that's a ream. That's 500 pages. Have you ever heard of a dozen? That's a number. What is it? 12. What else is there?
The baker's done.
A baker's done. A couple. It's
A score.
2. A couple's 2.
Yeah, usually. What?
A score.
A score is.
Score.
Okay.
Years ago.
Are you understanding here a little bit what really, guys, I'm gonna tell you why this mole is specifically that number. There's a uniqueness and a reason why this is the number that they chose. But I'm telling you right now, all a mole is it's just a number. Okay, Now let me show you or explain to you why scientists chose that number as a special, unique number. Can I do that for you? Okay. Do you remember talking about these numbers?
Okay.
What were those numbers?
Atomic mass.
Atomic mass unit, right? So what I said is if I have one atom of potassium, it has an atomic mass of what?
39.06.
It helps your immune system.
8-3.
Go 983.
Okay, now stop and think. You guys really need to pay attention here because I say that it's not so bad, but it's not so bad if you're paying attention. It's bad if you're not paying attention. Okay, because you have to understand the concept of the mole because everything is dependent upon that in this chapter. Okay? So when we looked at it, we said, if I have one atom, one itty bitty little atom, we said, this is what its mass is. And we were like, I have no idea what that means. Right? Does any of us have any kind of comprehension as to what an atomic mass unit is?
Yeah.
Yes.
It's really Isn't it about
It's like-
same as
it's actually really
one
easy.
carbon or something?
Yeah, well, they define it as,
That's all carbon.
basically what they define it as is the mass of one proton or the mass of one neutron. That's essentially what they define an atomic mass unit as. But what I'm trying to say is that a unit that we're familiar with and that we can understand? No, because it's such a small unit, right?
Right.
Okay, well, if I have 1 mole of potassium, which remember, how much is a mole?
6.022 times 10 to the 23rd.
If I have, so 1, that many difference, right?
Yes.
Okay, but what's interesting is this number stays the same, but it's a different unit. It's a more meaningful unit. If I have a mole of potassium, I have 39.09 grams of potassium. That makes sense to us, doesn't it? We know what a gram is, don't we? Now, we know that certain particles weigh more than other particles, right? Like lithium is smaller than potassium, right?
I think so.
Okay? So here's 1 mole of aluminum. So I've got 6.022 times 10 to the 23rd aluminum atoms here. Yeah, but
Pass it around.
here I have a mole of copper.
Were those pennies ones? I think those are just pennies.
Ew, why are they black?
Wow.
Here I have a mole of carbon.
So heavy.
Why are they black?
So if you put them
Wow.
together synthetically, they would become black.
Wow.
Here I have a mole of sucrose.
Those are some nasty pennies. Holy crap.
I think
Is it sugar? It's spilling, it's spilling.
Really?
Yeah, it's
No longer a mole.
Now I don't have a mole anymore. Way to go,
That was
guys.
6.022.
Oh, now here I have a mole of salt.
Or do you?
What is true about all of these? Stop and listen. This is a very important question. What is true or equal about all of these things?
You're a mole.
The number.
Well, what does that mean?
They're all 6.022 times 10 to the 23rd particles.
Yes, that means that I have 6.022 times 10 to the 23rd atoms of aluminum. I have 6.022 times 10 to the 23rd or 4 million units of salt. I have 6.022 times 10 to the 23rd atoms of carbon. I have 6.022 times 10 to the 23rd moles of the molecule sucrose. Now notice, is their mass all the same?
No.
Remember how we talked about how I have a mole of atoms, or sorry, a mole of apples and a mole of grapes. Same amount, different what? Mass or weight.
What would happen if you liquid carbon?
It would taste nasty.
Like, is it like
Yeah, essentially. Okay?
purple?
So, here's why this number is so significant. Is because these numbers that we originally equated to an atomic mass unit now become a more meaningful unit to us the gram. So, if I have a mole of strontium, I would have 87.62 grams of it. So, couldn't I weigh 87.62 grams and know exactly how many atoms of strontium I had? Okay, and couldn't I scale that up or scale that down proportionally to figure out if I have half a mole or 2 moles or 17 moles?
So that number
You
you
can
convert
sucrose.
atomic mass to grams.
Yep.
You eat sucrose.
Yeah, but
It's sugar.
I don't know how, that's pretty old.
No, it's
Do you won't?
Yeah.
Okay, so please, I do want you guys to focus here because, so a mole is referring to the, when we're talking about chemistry dealing with particles, there's another name for it called Avogadro's number, okay? Now, I want you guys, let this, don't mess around here. I want you guys to write this down somewhere. There are 4 types of particles. When I refer to a particle, I could be referring to one of these 4 types. The first type, I could be talking about the particle atom. An atom is a particle. I could be talking about a charged atom. What do we call those?
Cat ion? Ion.
Well, you're not wrong.
Well, I mean, that's.
I could be talking about a molecule, which is a what type of compound? Please somebody answer that question.
Valent.
Yes, thank you. And I could be talking about a these are all types of particles. Okay, but remember, okay, if I have a mole of atoms, how many atoms do I have?
6.022
If I have a mole of ions, how many ions do I have? If I have a mole of molecules,
A mole.
I'm trying to make this so repetitive because I want you to understand that a mole is just a number. Now remember, what's likely to have more mass? A mole of atoms or a mole of molecules? Because molecules are made up of
More
atoms. Right?
Yeah.
So, when I say, not that. When I have something like this, let's say I have a mole of this whole formula unit. There's a mole of calcium in there, and there are 2 moles of chlorine in there. Okay? If I say I have a mole of sandwiches, wouldn't I have 2 moles of bread?
Oh.
Right? If every sandwich has 2 pieces of bread, and I have a mole of sandwiches, wouldn't I have 2 moles of bread? Okay? Depending upon how many pieces of meat you, say you put 4 pieces of meat on every one of those sandwiches, and you had 1 mole of sandwiches, how many moles of meat would you have? 4 moles. It would be 4 times 6.022 times 10 to the 23rd. Okay? I'm getting next level on this with you. I'm just trying to make the connection here that you can have a big particle broken up into smaller particles, but you would have more pieces of them. If that makes sense. Right? If I have a full sandwich, that's 1 particle. If I break that sandwich up, I have smaller pieces, more pieces, but if I add them together, I still should have the same mass, right? Anyways, let's progress. I'm spending a lot of time lingering on making sure you understand this. Okay. Oh, I didn't want to do that!
Maybe those coal basics there.
Okay, let's apply this. Okay, you should have a math problem there. I just said, this is something you're going to want to know, 1 mole equals 6.022 times 10 to the 23rd particles. Doesn't matter what type of particle it is, we can identify that as we progress. Those equal each other, so couldn't we use them in a unit converter?
You do it.
And we're about to do it. Okay, so now notice, it says, how many atoms are in 4 moles of aluminum, or not aluminum, of helium?
4.0.
Okay? So I have 4.5 moles of helium. Now I know how many atoms are in 1 mole of
You
helium.
gotta multiply it by 6.022 times 10 to the 23rd.
Be careful. You're right in this context, but it could be different. Let me show you what I mean. We're going to use this as a unit converter. So we are going to set up a conversion factor. Now notice, there's a unit that I have to cancel out. What is it?
Mole.
Where would it go?
Bottom.
And what am I trying to solve for?
Grams. No, wait.
Atoms.
Nice, Marty.
It isn't an atom a type of particle?
Whoa.
So for every 1 mole, I know I have 6.022 times 10 to the 23rd atoms. And if I have 4.5 moles of it, it would be 4.5 times that number. The reason why I say be careful just assuming multiplication is, what if I said I had 6.1 times 10 to the 27th atoms, and I want to know how many moles there were? In that situation, you would divide. Okay? That's why setting up a conversion factor and figuring out how these cancel out will help you with this. For the sake of time, I'm just going to give you what the answer is. Just remember, when you're doing scientific notation, make sure that you put parentheses around it when you are doing it in your calculator.
Oh, you got that?
It's a lot of atoms.
It's a lot of atoms, but notice, I can count how many atoms I have if I know how many moles I have. And I can know how many moles I can know how much mass I have by how many moles I have too, which we're going to get to that here in a sec. Couldn't I flip this? Couldn't I start with this many atoms, flip the conversion factor, and come up with 4.5 moles of helium? Just like if I were going from feet to centimeters, not centimeters, feet to inches, I could also go from inches to feet using the same conversion factor. Okay. Progress. So molar mass. So I'm giving you 2 conversion factors today. The first conversion factor is this. The second conversion factor is, if I have a mole of something, I have X amount of grams. And why did I put X amount of grams? Well, it depends upon what I have a mole of. Does that make sense? Because if I have a mole of potassium, what's the X in grams here?
That number.
39.09. Okay, if I have a mole of nickel, you see how it's a different mass. And if I have a mole of carbon, it's a different mass. Does that make sense?
So it's like if you have 2 feet of yarn, you also have 24 inches of yarn.
Yeah.
But
you could say, yes. But if you're talking about like the same type of yarn,
okay.
excuse me, it's not quite the same analogy. Okay?
Dang it.
So then it says, how much mass 1 mole of a particular particle would have. Now we could have an ion, we could have an atom, we could have molecules, we could have formula units. We're going to start out with the easy ones and just deal with atoms. Okay, eventually, we're going to find the mass of compounds or molecules and formula units, which has multiple atoms in it, right? Right? Let's do this. Let's take that same idea, still dealing with helium here. We know we got a half a mole of helium. Let's figure out how much that would weigh, or what that mass of that would be. So again, like our typical problems that we did in chapter 3, you again start with what you've been given. I have a half a mole of helium. And what do I want to know? What am I solving for?
How many?
The mass.
Grams.
Grams. So essentially, I want to convert moles to what?
Grams.
That conversion factor is known as your molar mass. And where will you look every single time when I ask you to find molar mass? A periodic table. These numbers in the left here are your molar masses. If I have a mole of any of these things, this is what they weigh. This is what their mass is. Everyone see it? So whenever I ask you to find molar mass, where should you look to? Your boyfriend or girlfriend? They got all the answers.
So easy to stay for countries.
What?
Yeah, I think it's right on the bed. Just like,
Okay, so notice I have moles on bottom again here. Why?
Got
Because
it.
you
Cross
cancel.
Because I have
out.
to cancel and I want to go to grams. And I know that up here is for every 1 mole, right? So for every 1 mole, how many grams of helium would I have? Oh, quick little, this is really important. Because obviously there's a lot of different decimals up here, right? Okay? For simplicity of helping me be able to grade and being consistent, when we're doing molar mass, I always round to the 2nd decimal place. Does everybody understand what I said? If you need to write that down to remember, do it. Because I don't want you to put everything in, because if Brevin puts the whole number in and Quinlan puts a smaller number in, you're going to get different answers. So I want, for consistency purposes, always round to 2 decimal places when you're using the molar mass on the periodic table. Okay, so I'm going to look up here, and I'm going to go, I'm not going to use the whole number, I'm just going to go to the 2nd decimal place and round there, so 4.00. Now this is pretty easy. If I have half a mole, and a mole is 4 grams, what would a half a mole be? 2. Now I'm giving you easy numbers here to work with. Would you be able to do that in your head if you had 0.237 moles? No. Okay. Could I then also say, hey, I've got 52 grams of helium. How many moles is that? Could I solve for it? Yeah. Yes. Just doing the opposite. I'm guessing that's what's coming up. Nope, nope. Is this in your notes anywhere? Okay, I'll give you a sheet that has this in a little bit. What I'm trying to show you here is we've talked about, we really have 2 conversion factors. We have the conversion factor that's able to convert moles to particles, and we have a conversion factor that's able to convert moles to what? We just did it. Yeah, mass. Okay? Notice everything runs through the mole train. So do you see how now I can count how many particles I have by weighing them through the what train?
Oh.
So what I can do is I can figure out if I've got 42 grams of a substance, I can tell you exactly how many particles I have by converting it to moles and then converting moles to particles. And you see the double arrow? That just means I can go either way, right? You can go either way when you're converting anything, correct? If you want to call it that. Here's where we're going to do it here. Notice that it says I've got 4 grams of copper, and I want to know how many atoms that is. Notice it didn't say how many moles that is. So this is going to be a 2-step problem. Okay, and let me show you. Because what I'm doing is I'm starting here, and I'm going where? Do we have any conversion that allows me to go straight from mass to particles? No. And the reason why we don't is because every element up there has a different mass. Okay? So let's do this. It is a 2-step problem. I'm going to start again with what I've been given. But now we're talking copper here, correct? Following so far? And we want to know how many copper atoms that is. So, everything flows through the mole train. I got 2 conversions here. Okay? And I gave you 2 conversions. 1 mole equals X grams, right? Okay, so I have to convert to what first before I can go to particles?
To
Moles. Okay? By canceling out what? Grams would go on bottom, converting to moles. Let me just finish with this and we'll be done. Okay? Now, I could put in numbers now, but couldn't I like continue the unit train and get the units all figured out and then put the numbers in? What has to go here? And what am I solving for? Atoms, right? Right? I want to show you something unique. Isn't that what the conversion's always going to be when we've got moles for these two conversions? Now, I got to find the mass. Where would I look to find the mass?
The corner.
Periodic table, you come up here and you go, copper, a mole of copper is 63.5, rounded up to 5.5. And then we know Avogadro's number is just a constant number. What is it?
6.0222 times 10⁻³
Okay, so stop and listen here, because you can do all this at once, but I find it easier to take it a step at a time. Listen before I let you go. Okay, you're going to take 4. Anything on bottom you do what with? Divide. Anything on top you?
Multiply.
Do you even need to worry about the ones?
Not really.
So here's how I would do it. I would take 4 divided by this, solve. Take that answer and multiply it by this, solve.
That's what I do.
You're going to get the right answer a lot simpler that way. Let me get you the correct answer here.
That's what I do.
3.79 times 10 to the 22nd copper atoms. I'm going to stop for a second here. Let me just make a critical thinking connection here. I know we're running out of time here. We ran out of time. Did I have enough for a mole of copper?
No.
No, because I know a mole of copper is this, right? Correct? So shouldn't I have less than a mole of atoms?
Oh, yeah.
And we do, don't we?
We do.
We do. That's one way to check. Now listen very, very carefully. I'll let you go. Okay? We found out how many particles we had by mass. So essentially we counted our atoms by weighing it. Just like the jelly beans. You guys are done. Jelly.
That was annoying me all class, and I finally got to ask, and he doesn't even have an answer. His